In the Orion constellation resides a star that has intrigued astronomers for centuries. This star, known as Betelgeuse, is a red giant vastly larger and more massive than our Sun. However, in recent times, Betelgeuse has exhibited unusual behavior, dimming significantly and experiencing violent oscillations. These phenomena have sparked theories suggesting that this star may soon undergo a supernova explosion. But what if we are witnessing the onset of something even more terrifying? What if Betelgeuse is not heading toward an explosion, but instead toward a collapse within itself? 33 seconds. Join us as we embark on a journey to the shoulder of Orion's Hunter, examining these changes in Betelgeuse in detail and exploring the potential impacts for Earth. Betelgeuse is an incredibly massive star, approximately 1,000 times larger than our Sun. While its grandeur is awe-inspiring, it also carries the destiny of massive stars, a finite lifespan that could trigger a catastrophic supernova. The uncertainty lies in the exact moment of this inevitable collapse, making it a cosmic time bomb and a mystery to scientists. Situated just 650 light-years away, Betelgeuse has captured the attention of astronomers with its radiance. We marvel at its brilliance while trying to decipher the mysteries concealed in its fiery depths. Surprisingly, only about 13.3% of its total energy is visible to us. If we could witness its full glory, it would outshine even Sirius, the brightest star in our night sky. 1 minute and 40 seconds. Picture a colossal star with a radius 1,000 times that of our Sun, extending past the asteroid belt, almost touching Jupiter. Within this vast space, Earth, Mars, Mercury, and Venus would be swallowed by the irresistible cosmic pull of Betelgeuse. But the intrigue doesn't end there. Every millennium, this star sheds a solar mass, creating a spectacular nebula. This nebula, 250 times larger than the star itself, envelopes Betelgeuse in an ethereal mist that stretches up to 30 astronomical units, inviting us to witness a cosmic dance of wonders. 2 minutes and 18 seconds. Within the core of Betelgeuse, the process of hydrogen fusion is at work, where helium ignites in a cosmic explosion. Over time, as the star's hydrogen supply is exhausted, a celestial transformation begins. The star starts fusing carbon, unleashing a brilliant glow across the cosmos. However, this fusion process has limits. When iron forms, the star undergoes a critical shift. Its gravitational pull diminishes, causing an inevitable collapse that sends Betelgeuse toward a fate both awe-inspiring and destructive, a supernova explosion. 2 minutes and 54 seconds. This colossal celestial event releases energy equal to that of 10 billion suns, producing unimaginable power that resonates throughout the universe. Stars undergo incredible evolution, shifting from youthful blue hues to the fiery reds of maturity. In the 2nd century BC, Chinese stargazers made a fascinating observation, noting the distinctive red color of Betelgeuse that set it apart in the celestial tapestry. Eventually, this observation reached the keen eyes of the Greco-Roman astronomer Ptolemy in the 2nd century AD, who recorded Betelgeuse as having an orange or reddish appearance, a feature that continues to capture our attention today. 4 minutes and 3 seconds. The consistent red coloration of Betelgeuse across civilizations, including those of the medieval Middle East, adds to the allure of its enigmatic nature. The narrative of Betelgeuse takes a surprising turn when we examine its recent behavior. In 2019, the star puzzled scientists by suddenly dimming in brightness. Initially, it was believed that a large dust cloud shed from the star's surface was blocking our view, but the origin of this dust cloud remains unclear. Some scientists speculate that a large object, such as a planet, may have disturbed the star's surface or even been absorbed by it. More recently, Betelgeuse has exhibited an increase in brightness, reaching about 150% of its average luminosity, an unexpected phenomenon, as stars generally become dimmer as they age. 4 minutes and 35 seconds. Scientists remain uncertain about the cause behind this increase in brightness, though they understand that stars can experience fluctuations in luminosity for various reasons. Some stars, such as Mira, known as the Wonder Star, go through cycles of expanding and contracting, affecting their brightness. This phenomenon is common among many stars, including Epsilon Orionis, visible to the naked eye without a telescope. In the core of Betelgeuse, a seismic shift is taking place as material is ejected into space, forming a magnificent dust cloud of vast proportions. This celestial dust obscures a significant portion of Betelgeuse's radiant light, transforming it from a glowing beacon to a dimmer luminary in the night sky. Its brightness has dropped drastically, falling from one of the 10 brightest stars to among the 20 brightest in recent months. 5 minutes and 41 seconds. Betelgeuse has defied expectations, leaving scientists around the world baffled by its extraordinary behavior. Various theories attempt to explain these dramatic fluctuations. Some propose that massive sunspots or dust clouds are responsible, while others suggest the possibility of coinciding cycles. Research has led to an intriguing theory: the supernova explosion may have already occurred. Yes, you read that correctly. While previous projections suggested that a supernova would take place hundreds of thousands of years from now, there is now evidence pointing to a different reality. 6 minutes and 12 seconds. Some scientists believe a supernova has already happened in our galaxy centuries ago, known as the Kepler supernova, which still graces the heavens with its brilliance. Researchers have developed a model suggesting that Betelgeuse is in the final stages of carbon burning, which could mean it is on the cusp of an immense explosion. This makes Betelgeuse a strong candidate for the next supernova in our Milky Way galaxy, marking the grand finale of a cosmic symphony. 6 minutes and 42 seconds. However, understanding Betelgeuse is akin to solving a puzzle due to conflicting observations. It has shown massive ejections of material followed by recovery, suggesting a mass ejection event, though not on the scale of our Sun. Supernovae are real phenomena, and one was observed in a satellite galaxy of the Milky Way in 1987. While the exact timing of Betelgeuse's explosion remains uncertain, there is no time to plan for it. It remains a subject of ongoing research. 7 minutes and 15 seconds. The challenge lies in the difficulty of observing Betelgeuse in its entirety. Although scientists have studied the star for centuries and noticed changes in its brightness, there is not enough data to predict exactly when it will go supernova. A supernova is an intensely bright explosion that occurs when a star reaches the end of its life. While it is harmless to life on Earth and safe to observe with the naked eye, a supernova's brightness depends on the size of the exploding star. Since Betelgeuse is enormous, its supernova would be incredibly bright, potentially outshining the Moon and visible even during the day. 7 minutes and 47 seconds. Although predicting Betelgeuse's fate remains an ongoing mystery, scientists continue to closely monitor this enigmatic star. Its behavior and the possibility of a supernova have left many researchers pondering the cosmic clock ticking away with each fluctuation in brightness. As we look up at the night sky, we can't help but wonder if a spectacular supernova will soon unfold before our eyes, or if we are witnessing a new chapter in the life of this massive celestial body. As months pass, Betelgeuse's behavior becomes increasingly erratic. The star's brightness fluctuates unpredictably. One night, it outshines every star in the sky, and the next, it dims so drastically it nearly disappears from view. The scientific community is on edge, watching, waiting, and preparing for what could be the most monumental cosmic event in human history. Then, without warning, the unimaginable happens. A sudden pulse of energy, stronger than anything detected before, erupts from Betelgeuse. Telescopes worldwide capture the moment as a brilliant flash tears through the darkness of space. The shockwave races outward at the speed of light, carrying with it the echoes of an ancient giant's final breath. On Earth, night turns to day. Across continents, people look to the sky in awe and fear as Betelgeuse explodes into a brilliant supernova, outshining even the full moon. The once distant star becomes a cosmic beacon, visible even during daylight hours. But this is only the beginning. As scientists scramble to analyze the event, they notice something unusual. The explosion doesn't behave like any supernova they've ever witnessed. Instead of collapsing inward to form a neutron star or black hole, Betelgeuse's core seems to resist the gravitational collapse. Advanced sensors detect a strange energy signature, one that doesn't match any known force in the universe. Theories begin to swirl. Some scientists speculate that Betelgeuse might be undergoing a hypernova, an even more powerful explosion than anticipated. Others whisper of something entirely new, the creation of a quark star, a theoretical object even denser than a neutron star. Weeks later, a ripple of gravitational waves reaches Earth. It's stronger than anything humanity has ever recorded. As the data comes in, astrophysicists are stunned. This isn't just the death of a star, it's the birth of something entirely unprecedented. Then, deep within the remnants of the supernova, telescopes capture a strange phenomenon, a glowing, pulsing core surrounded by an ethereal, spiraling cloud of energy. It pulses in a rhythmic pattern, steady, intentional, almost like a message. What if Betelgeuse's final act wasn't destruction but transformation? What if, in its dying moments, it became something entirely new, a cosmic intelligence born from the heart of a dying star? As the days stretch into weeks, the strange signals from the heart of the supernova grow stronger, more structured, more deliberate. Patterns emerge within the pulsing energy, sequences of prime numbers, mathematical constants, and geometric shapes too perfect to be random. The global scientific community is in a frenzy. Teams from NASA, the European Space Agency, and private space research firms collaborate in an unprecedented alliance, trying to decode what many now believe could be an extraterrestrial message. The implications are staggering. What if Betelgeuse's transformation has birthed a new form of consciousness? The world watches in awe and fear as more signals pour in. A breakthrough finally comes when a young astrophysicist, Dr. Amina Patel, notices something remarkable. The pulses mirror the electromagnetic signatures of human brainwaves, specifically those associated with thought and memory. What if it's not just a message, she proposes? What if it's thinking? The possibility sends shockwaves across the world. Could Betelgeuse have evolved into a sentient cosmic entity, a living star? If so, what is it trying to communicate? And why now? Then, the pulses change. A new sequence begins, transmitting images, complex, shimmering patterns of galaxies, star systems, and ancient cosmic events. But embedded within these breathtaking visions is something even more astonishing: a map. A pathway through the galaxy leading toward a specific region of space, an uncharted system hidden deep within the Orion Arm. Speculation explodes across the scientific community. Is Betelgeuse pointing humanity toward something? A message left behind by an ancient civilization? A warning? Or perhaps an invitation? With urgency growing, the world's governments come together for a bold decision: to launch Project Dawn Star, the most ambitious space mission in human history. A state-of-the-art spacecraft, powered by cutting-edge propulsion technology, is built to follow Betelgeuse's map. On board are the finest minds of humanity: scientists, explorers, linguists, and engineers, all ready to unravel the mystery that could redefine humanity's place in the cosmos. As Dawn Star launches, leaving Earth's atmosphere behind, the world holds its breath. The journey will take years, but the crew is prepared for the unknown. Back on Earth, the signals from Betelgeuse continue, steadier now, almost as if waiting. As the Dawn Star travels deeper into the void, humanity stands on the brink of a discovery that could either reveal the universe's greatest secrets or awaken something far beyond our understanding. The question echoes through the minds of every scientist, dreamer, and skywatcher. Did Betelgeuse simply die, or did it become something unimaginable? And when humanity finally reaches the end of that cosmic map, what will be waiting for them?